Lab Guy here. Here's another dreaded update video. The first update will concern the NBTV Dissectorcam project. I'm working on it actively. I have nothing to show you that is actual progress, as I'm kind of stuck between a rock and a hard place when it comes to optics. Let's look at that now. If you'll recall, in that project, I was having trouble getting the back focus of the lens correct. I 3D printed the front lens holder to place the lens at the correct distance from the camera tube face. The problem that I ran into was that I didn't have it the correct distance. So I printed a thicker, I don't know how you can see that, I printed a thicker disc, and that made the problem worse. So the next step was to print a thinner disc, which I did, and unfortunately the thickness came up even with the mounting system of the tube, and this lens mount, which screws into the center of the 3D printed part, is too thick already. It's protruding into the inside of this body here, which is the medium, and on this thinner one, because we've already bottomed out on the tube, there is nowhere to thread the metal D-mount. I believe this is called a D-mount thread on the outside, and a C-mount, it is a C-mount on the inside. Well, it is already too thick and has bottomed out. Even with this piece, it has bottomed out against the front of this tube mounting system. Now, it's possible for me to shorten this a little bit at the risk of damaging the deflection yoke, so I'm still pondering that. What I've come up with is an alternative solution. I'll use this disc that has bottomed out even with the face of the tube, and I will change lenses. I purchased on eBay a Nikon camera bellows, which will allow me to use a Nikon camera lens, and I will be able to position it as necessary relative to the face of the tube. Now, it has a Nikon camera mount on the back side, which I will remove and attempt to mount this unit flat to the camera housing like this. I've just ordered a wide-angle Nikon compatible lens to put on the front of this unit, but as you can see, as you may or may not be able to see, that actually looks like it's working. No. This unit itself is too tall to line up centered on this camera tube. The solution to that will be reasonably simple. I will unmount the camera barrel, which has these little legs underneath that it sits upon, and I will 3D print some extensions to raise it up, to bring it properly level with this shoe in place. So this tube will rise up quite a bit, and I will move it back so that this assembly can be bolted to the top of this box, if you can follow what I'm saying. And so fortunately, the entire assembly itself can move on the mounting shoe. So we will, the mounting shoe takes a 1/4 bolt, so we'll fix it up so that this is bolted to the front of the box, that the camera tube is raised up to line up with this opening, and then this unit actually will be capable of going back over the top of this tube, and in theory, the new lens will be able to focus, will be able to be positioned relative to the tube at the right point where its normal natural focusing will work, so that I can get pictures of objects farther in front of the camera than I currently can. If you'll recall, with this lens on here, I was able to focus the camera onto Felix the cat when he was sitting just about this far out. Not very far at all, right in front of the camera. So the lens is too far away from the tube. In this case, the back focal length of these television cameras is very short behind the lens. These have a deeper throw to the focal plane. So hopefully that will solve this problem. At least that's the current solution that I have in mind for the NBTV Dissector camera. The next phase with this camera will be the electronics, which is currently set up to display the image on an oscilloscope, but I will be changing that soon to output a composite video signal, which we will be able to see on the NBTV CRT monitor and on my NBTV mechanical monitor. So stay tuned for that as well. The next project that I've been working on is, of course, the Cartrivision Portapak project, which is a kind of a novelty item that I whipped together on impulse, and it is 99% complete, and there's just a few details to work out. Let me show you what those are right now. Moving on to the Cartrivision Portapak project, there are several issues to be dealt with, but they're coming along nicely. The one was that I needed a proper cable to connect the camera so that I could get all of the features of the camera to work. There is initially the pilot light circuit for this silly light on top of the camera, so that when we work the switch on the stereo microphone, it will turn the light off and on, which an interviewer holding the camera can utilize to let the interviewee know that the camera is recording. That will require a constant current circuit because the lamp in here is wired in parallel with the button, so that if you push this button, what happens is it shorts the lamp, and if you simply have a series resistor with the lamp, the series resistor will burn up, or at least overheat severely. So I'm going to put in a current circuit. This lamp wants 15 milliamps at 10 volts. So I'll derive that from the 18 volt circuit, and it'll work in such a way that if you press the button, the circuit can only draw 15 milliamps, which is harmless, and nothing will happen. At the remote end inside the recording box, if I wanted to, and if I can figure out how to, I can use it to trigger the clear click recorder itself to start and stop. That would be very good. Then you could activate the recording from the microphone and from this button on top of the camera, where it would be possible, theoretically, to use the microphone switch to place the system into record mode, and then use the button on the camera to start and stop recordings. That's a theory, anyways. Since the last video, I added a clear plastic safety cover over the screen, since the way this sits, facing straight up, obviously it would be possible to drop objects onto the LCD and damage it. So this piece of plastic is from a bubble pack package of when you buy things, and this package contained a hard drive. So I use this clear plastic as a sacrificial surface in the event that something falls on it. I don't believe I've ever shown the front of the clear click recorder in detail, but this is it. And so Pretty much the electronics are complete inside the unit, and it is already usable. I need to go find a location that's appropriate and do an on-site recording using the Cartrivision camera. This is camera number 7, which I rebuilt in the videos that we've been watching. And when I bought that bellows for the NBTV camera, it came with this pistol grip, which will attach to this camera nicely. I have 7 cameras and 7 pistol grips, but for the Cartrivision camera there's a special screw that you put in to attach the Cartrivision pistol grips, and I only have 6 of those screws, so I have 1 extra orphaned handle, which I'll probably put on eBay for somebody who has a camera but no handle. If you have a camera with that screw in the bottom and no handle, contact me and we can work out a simple deal. So this is camera 7, which has been fully restored. All the capacitors were replaced. It was electronically aligned. The tube was replaced even. The door works on the lens. The aperture switch works on this camera. We have reached all of those milestones. This is the power cable connector, which connects the camera to the input on the recording unit, making this into an actual video Portapak system. Now the camera has this cheesy through the lens viewfinder, which is, to be polite, useless. It's completely useless. You can't. Your eye will autofocus through the lens, so whether the camera's in focus or not, your eyeball says it's in focus, and you could be shooting a blurry video and not know it. And so the proper use of this system is to look at the picture on the clear click monitor to adjust the focus. So that is the current state of this project. A while back, I posted some videos about my Hickok 760 television serviceman's flying spot scanner, which scans a monochrome plastic slide and produces a video signal for servicing television sets. That device was built in 1957. What I didn't mention at the time was that I have 2 of them. The one that I showed in the videos was a complete unit, and it was operational after a fashion. I was able to bring it to life and demonstrate it without having to do anything to it. Now, it's not perfect, and it will require capacitor replacements and so on. And I will put a link in the description to that video for you to see that. I got very low response on that video. I don't know why. At any rate, I have a second unit. It's missing the tubes. Somebody has stolen all of the tubes out of the chassis. It's in sad condition. It was not kept dry its whole life. The wooden cabinet is in deteriorated condition. I believe the wood is okay, but I could be wrong about that. Certainly that glued on cloth covering on the outside is rotting away. And as mentioned, the tubes are missing. And worst of all, the reason I put no effort into it is somebody stole the crystal, the quartz crystal that is the heartbeat of the system. My working unit has the crystal intact, and the non-working unit is missing the crystal. Now, it has taken me some time to burn up pencil and paper working out what standard crystal can I get and build a small oscillator that will produce the 315 kilocycles that the Hickok generator requires. Now, if you know your TV numbers, 315 kilohertz is 10 times the frequency of the oscillator in the Cartrivision camera. The Cartrivision camera runs an oscillator at 31.5 kilocycles. Again, referring to our television, black and white, numbers, 31.5 kilocycles is 2 times the 15.75 kilocycles of horizontal scan. So in the Hickok generator, they start with an oscillator that is not 2 times the horizontal frequency, but 20 times the horizontal frequency, which they divide down using blocking oscillators, which is the analog electronics equivalent of digital dividers. They're able to divide by prime numbers specifically. 3, 5s, and 7s are common. And by combining these, you can divide down any frequency down to a desired frequency by factoring. There are many good videos on YouTube about factoring a number. So if we have 31.5 kilocycles and we need to get to horizontal sync of 15.75, that's very easy. We divide by 2 using a digital flip-flop, which could be a pair of transistors or a pair of triode tubes. Either way works. In the case of the 315 kilocycle oscillator, they divide it with a series of 5s and 7s and 3s blocking oscillators. I believe there's a total of 4. I don't remember the exact sequence, but that is the issue at hand. So back to my crystal situation, a 315 kilohertz crystal is clearly not made of quartz. It's made of a substance called unobtainium, and it's just not available. I contacted several crystal companies that claimed they would make custom crystals for anybody. It's a false claim. They didn't even want the job, and I was willing to pay $100 for this crystal. I mean, this is a ridiculous amount of money to spend on this video generator in the condition that it is currently in. The only tube left in it is the CRT, the scanning CRT. So I think it's worth restoring because these devices are very, very rare as compared to the B&K 1076 and 1077 scanners, which you can find frequently. There's a lot of those out there. They're not as good as the Hickok unit. The Hickok unit actually produces 2-to-1 interlaced sync. The B&K units are free-running random sync units. Now they're totally adequate for repairing a television set. So back to this crystal and the oscillator, I was playing with the numbers, and using digital dividers you can divide by 2, 4, 8, 16, 32, 64, etc. And looking at standard crystals, I tried dividing those numbers by those factors and discovered that 10 megahertz divided by 32 came extremely close and probably was close enough to make that thing work. It would produce a 2-to-1 interlaced video signal, not quite on the exact numbers, but probably close enough to lock a television set. But I didn't think that was good enough, and it turns out that 32 times the 315 kilocycles comes out to 10.08 megahertz. That sounded familiar to me. So I searched, and sure enough, I was able to obtain a 10.08 kilohertz crystal. And that can be divided down by a simple 5-bit binary counter. I will build a little circuit board that will get power from the filament string in the Hickok 760 video generator, and will operate in place of the original crystal, and we will be able to divide the 10.08 megahertz crystal to 315 kilohertz and inject it into the system and make it work. So now it's worth my time to hunt down the vacuum tubes required to restore that unit. So that is a future project coming up. And I know that was a very long-winded explanation to get there. But what it's about is this silly little El Cheapo under $10 kit, which is a crystal tester kit. It's also a frequency counter. So it's useful. I think it goes... I'm not sure what the upper frequency is, but It certainly goes to 10 megahertz, and my 10 megahertz crystal, when I inserted it into the test socket, right here, there's a little test socket right there. It's probably out of focus for you. Anyways, this display said 10.080. So I was very happy that I got a working crystal, so now I can tell you about that project. That is a future project, but a unit that essentially was destined for the recycler can now be brought back to life. And attention woodworkers out there, if anyone out there is a home hobby small cabinet maker, jewel box maker and stuff, contact me. I can take the 760 out of the box. I will send you the rotten box, and perhaps for a reasonable fee you can make me a nice replacement wooden box for this device. So like I said, you can talk to me about that. And that's where that project now sits. The next subject I'd like to cover. As you know, in the Cartrivision Portapak project, I had to get a source of 60 cycles for operating the Cartrivision camera. If you are working on your Cartrivision camera and wish to duplicate the 18-volt boost regulator circuit and need the 60 cycle reference, contact me. I have the 60 cycle chips and the matching crystal, and we can work something out. I'm not going to profiteer on this, but probably $10 for the pair and postage, and you can have the basis of the oscillator, and I even have the tuning capacitors to throw in to go with it, and you will be able to then build your own 60 cycle reference. Also, for you guys who build digital clocks and you're using like a 5314, I believe, is the original what's their name? National Semiconductor clock chip. It also requires 60 cycles to run the clock. These chips are made for that as well. So if you need a 60 cycle pulse for any project, here's a way to get that for probably around $15. You're ready to go 60 cycle reference kit, and courtesy of Lab Guys World. You're welcome. Back to the subject of NBTV again. You remember the little NBTV CRT Televisor. It works very, 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 very well if you turn it on 20 minutes before you demonstrate it. It has a mild temperature problem, so that when you initially turn it on, the 1-inch picture is a half-inch picture. Otherwise, it's perfectly fine, but it's very small, and as the unit warms up physically and becomes hotter and hotter inside, the little oscilloscope generates quite a bit of heat, it turns out. The current source for the scanning circuits warms up and produces more current as it gets warmer. It's not an absolutely ideal current source, and there are 4 of them. 2 for the scanning amplifiers and 2 for the ramp generators. All 4 of them start out cold at a lower current than after they've warmed up. I have a solution for that, and we will be covering that soon. Concerning the mechanical televisor, which I'll show you a picture here. On the mechanical televisor, it is currently set up for RGB input and is actually incapable of displaying a standard black and white NBTV signal. It currently uses the black and white signal to synchronize the NIPCOW disc, and direct red, green, and blue video drives the LED Illuminator box. So I have the components to fix that problem on that monitor, on the mechanical monitor, so that we can switch it between color and black and white. And I am also going to add contrast and brightness controls that are tripled so that they adjust brightness and contrast on red, green, and blue in parallel. And for that I got some ganged potentiometers. I got enough of them to do the brightness and contrast of 3 parallel channels, and in parallel, obviously. And also these units, these potentiometer units, are not triples, they're hex. They have 6 potentiometers all in a row, all turned with the same knob. I have no idea what the application for that was. However, this gives us a contrast control for green, blue, red, and monochrome, and a brightness control for green, red, blue, and monochrome. So that solves my problem of not ending up with 37 knobs on the side of this mechanical TV, which you can get out of whack by having them in parallel. Brightness and contrast will track each other quite well, and that would be fine. And so that's coming up too. This is where we're headed with the NBTV projects. They're far from done, and I believe that I will come up with some very useful circuits that other NBTV experimenters will enjoy using. Another project that I put a lot of work into was the NBTV Ten Four Eleanore project, which is the color and monochrome NBTV still image generator. This unit can store 256 pictures in its memory, and you can select them with the selector knob to display on your mechanical televisions. The downside is they are still pictures. Now, it's possible to upgrade this in the future to produce loops of frames, kind of like animated GIF images, so that you can have some moving pictures on your mechanical TVs. But I didn't really build it for that. And there was a great deal of complaints about the way the images get into the memory chips, and I can't disagree with the complaints. You have to take the memory chips out of here. There are 3 memory chips, one for red, one for green, one for blue, and put them in an external chip programmer after you've gone through a huge rigmarole to get your little pictures transferred into the binary files that go into the memory chips. So, where is that headed? I am working on learning C# so that I can produce a Windows app that will make producing those binary files for your Ten Four Eleanore, if you decide to copy the project. It's documented on my website, www.labguysworld.com, under the Video and Electronics Project section. This application that I'm planning on writing will allow you to drag and drop a color image or a monochrome image into the app, and it will scale it appropriately to the correct size and allow you to select a region in the correct aspect ratio format. This is all in my head, how this app will function, and you will be able to zoom the frame window in and out, bigger and smaller. Say you have a picture of 4 or 5 people, and you'll be able to zoom in on a face with the frame and pick somebody, and that region, regardless of the number of pixels and lines that it's currently made of, will be rescaled to fit within the standard NBTV format of 32 scan lines by 64 pixels in my format. Many people do 32 lines by 48 pixels, and they kind of force fit it all into a single 8-bit ROM chip, which, I'm sorry, I just have to say it sucks. It's not the right way to do it. So anyways, this app will be made so that you can then more easily make memory chips for a Ten Four Eleanore should you decide to build one. So that's a future project that depends on my ability to learn C# and to write a Windows application. This will be made to run under Windows 10. So that's stand by for that project. Along with that project, I have been purchasing components and collecting them together. This is a small sampling of memory chips, A to D and D to A converters, and and a FTDI USB interface chip, which allows the computer to be connected to an external device. And this will allow two new projects that I want to do. I want to make a project similar to the Ten Four Eleanore that holds standard definition pictures in red, green, and blue in RAM memory. In this way, rather than having your images, your test images, in the memory chips, which are painful to pull out, program, put back in, they will be in files on your computer in a folder, and you'll have the app, and you want to see a particular picture on your television. Say you're troubleshooting a television, you can download to RAM memory. You will download the Indian head test pattern or color bars or just arbitrary pictures, and it will work very similar to the Eleanore, except it will be standard definition, and it will initially be built in 525/30i for American television, but should be easily adaptable to 625/25i European format television, including CCAM. But that's later. The box will initially produce red, green, and blue and monochrome output, which we will matrix into component video so that you can display it on a component television like your flat screen TV, and it will plug into the component inputs in that way. Or if you're just building a single frame memory, it will plug into your composite video input, and you'll have a monochrome frame buffer. I'm also planning on putting a front end in it so that it can capture standard definition monochrome images and have a selector switch so that you can route the captured image to the red, green, and blue memories so that you can use your red, green, and blue filter card in front of your monochrome camera to capture color images easily in standard TV definition that way. So anyways, these are some of the ideas I have. If you have input, if you have ideas for that, leave them in the comments. Thank you for watching this ridiculously long video about nothing. Essentially, it's an update video. The NBTV camera is the hot potato of my projects for me, and like I said, I have a lens in the mail. I need to do some mechanical rework to the camera chassis itself to accommodate the bellows and the lens and so on. And so that project is the current primary project. The Cartrivision Portapak is the secondary project, and the others are currently vaporware as they come along. And that should pretty much keep my calendar full for the year 2022. And if you have any other ideas for projects, let me know. Something that maybe you've seen in my repertoire that has tickled your funny bone or has interested you, let me know, and we can pursue those, because I don't operate from hard schedules, clearly, and I'm open to suggestions at all times, and I answer questions about video equipment, oddball formats, and standard definition stuff. I'm not so up on HD, and even though I'm capable of it, I'm not really interested in the HD stuff. That's pretty saturated market these days, right? So there you go. So I'd like to welcome all the new subscribers. Thank you for bearing with this long video again. Greetings to all the current subscribers. You guys rock. You're the best viewers on YouTube, you know. I mean, you have to be. You watch this channel. This channel can be frustrating and it can be rewarding. So I'm doing my best, and what else can I add? So thank you again, and until next time, Lab Guy out.